Hello students, in this video I am going to explain you about how to draw the shear force and bending moment diagram for a cantilever which is carrying UDL over partial span. Now here we have a cantilever beam capital AB which is fixed at B and free at point A of span 4 meter. It is carrying a UDL of 2 kilonewton acting over 1 meter over a span of 3 meters. Now for this thing we need to draw the shear force and bending moment diagram. Now what I am going to do here is I will consider a section in between A and C. Let us call this point as C. Now I'm just considering the first section over here. Let us take the first section number 1 and 1. Now this section is located exactly a distance of x from the free end capital A. Now shear force at any section 1 and 1 will be equal to, I'm just considering right side of the section, we have only one force which is acting in the downward direction. It has to be taken as positive. Shear force at any section 1 and 1 will be equal to the load which is acting over span of x, that is 2 multiplied by x with a positive sign. So it is acting in the downward direction. Right side downward should be taken as positive according to my sign convention. Then I am taking this one as positive. So plus 2 times x. Now shear force at any section x is equal to 0. That means exactly at point A, shear force at point A, free end A will be equal to 0. When I substitute x is equal to 0 here, you will get the value as 0. Next, let us calculate shear force at point C. That means shear force at a distance of x is equal to 3 meters. So this is plus 2 times 3 is 6 kilonewton. So 2 times 3 is plus 6 kilonewton. So exactly at point C we got the value as 6 kilonewton. Similarly, so in between A and C, we are just going in between A and C only now. After this one we will go with B and C. Bending moment at any section 1 and 1. Towards right side of the section, this 2 kilonewton is trying to push the beam in the downward direction, so it will create some hogging moment. It should be taken as negative. Minus 2 multiplied by x is the load, multiplied by x by 2 is the perpendicular distance. So we get minus 2 x square divided by 2, that is simply x square, minus 2 times x square divided by 2, so with a negative sign. So bending moment at any section x is equal to 0. That means bending moment at a point A, that is equal to 0 again. We got the value as 0. Similarly, bending moment at any section x is equal to 3 meters. That is bending moment at point C. So we substitute minus x square. This is minus 3 square, which is equal to minus 9 kilonewton meter. Now bending moment at point A is 0. Bending moment at point C, it is equal to minus 9 kilonewton meter. We got two values here. Similarly, shear force at point A is 0. Shear force at point C, it is 6 kilonewtons. We got two values here. Right. Now, the next thing is, let us consider a section in between B and C. I am calling this one as section number 2 and 2. Section number 2 and 2. Let us take this one as section number 2 and 2. Same thing again, this section is also located at a distance of x. At a distance of x. X is a variable. So exactly at distance of x. Now let us calculate the shear force at any section 2 and 2. So towards right side of the section, if we can calculate the total force which is acting, right, then it will be the same. Now exactly at point C or towards right side of the section, the total amount of force which is acting is 2 multiplied by 3. 2 kilonewton over span of 3 meters, that is plus 6 kilonewton. That means there is no other force. Exactly at point C, shear force at point C, it will be equal to plus 6 kilonewton. Similarly, there is no other force up to point B, then shear force at point B will also be equal to 6 kilonewton. Shear force at point B and shear force at point C both are equal to 6 kilonewton. There is no variation of shear force. It will be a parallel line to the baseline. Next, similarly, we have bending moment at any section 2 and 2. Now, bending moment equation, let us generate the bending moment equation. We have only one force here, which is pushing the beam in the downward direction, so it has to be taken as negative. So, load multiplied by perpendicular distance. Now, this load is acting over a span of 3 meter and it is located exactly at a distance of, this is half, and we have totally x distance over here. So, if I consider center of the load, right, here we have the center of the load. Now this center of the load is located exactly a distance of 1.5 meter from the free end. The remaining distance will be x minus 1.5. X minus 1.5. This distance will be x minus 1.5. Now let us generate the bending moment equation now. A bending moment at any section 2 and 2 will be equal to load multiplied by perpendicular distance. 2 multiplied by 3 meters. 2 multiplied by 3. 2 multiplied by 3 is the load, multiplied by x minus 1.5 is the perpendicular distance with a negative sign. So this will be bending moment at any section 2 and 2 is minus 6 times x minus 1.5. Now this is the equation. Now let us calculate bending moment at any section. X is equal to 3 meters. That means bending moment at point C. No need to calculate bending moment at point A again. Already we have calculated bending moment at point A and bending moment at point C also. Now let us for the section in between B and C. So whatever the thing which we are doing here, it is in section B and C. For the section in between B and C, we need to calculate the bending moment at C and check whether we are getting the same value or wrong. Right. So this will be minus 6 multiplied by 3 minus 1.5. So this is minus 6 multiplied by 1.5, which is equal to minus 9 kilonewton meter. We got one value here. Bending moment at point C, which is minus 9 kilonewton meter. It is similar to the value which we have obtained earlier for the section A and C. Similarly, let us calculate bending moment at a distance of x is equal to 4 meter. That means bending moment at point B. So here it will be minus 6 times 4 minus 1.5. So this will be minus 15 kilonewton meter. So we have minus 15 kilonewton meter. Right. So we got two values here. Bending moment at point B, it is equal to minus 15 kilonewton meter. Now how to draw the shear force and bending moment diagrams for the same thing? Same, right? The first thing what you need to do here is draw a baseline for shear force. Now exactly at point A and point B, let us mark the shear forces and also in between the point C. Now shear force at point A, it is 0. Let us call this one as 0, and shear force at point C is 6 kilonewton. I am just marking 6 kilonewton over here. This is 6 kilonewton. Next, the variation in between A to C, it will be linear. Just draw a straight line in between A and C. I am drawing a straight line in between A and C. Next, exactly at point B. Right now, let us go to the next section. Shear force at point C is already 6 kilonewton. Shear force at point B will be 6 kilonewton. Right here, it will be 6. The variation in between these two things is a straight line again, and it will be parallel to the baseline. So this is positive, again this one is positive. The maximum shear force we got here is 6 kilonewton. Right. So this is shear force diagram which we have drawn. Now I'm just decorating this thing. Next, let us draw the bending moment diagram. So same thing again, draw a baseline. Bending moment at point A, right? Exactly at point A, it is 0, and bending moment at point C. Exactly at point C, we have 9 kilonewton. Just I am marking 9 kilonewton over here, minus 9. No need to indicate my negative sign because we are drawing it in the downward direction. Next, bending moment at point B, right? It is equal to 6 kilonewton. This is not this one, right here. We have bending moment at point B, which is equal to minus 15. So I'm just marking minus 15, or just simply 15 kilonewton here, kilonewton meter. Now the variation in between A to C, right, as you can see the bending moment equation, right, we have minus x square. Hence the variation in between A to C will be a parabola. Just I am drawing a parabolic equation, a parabola here. Next, the variation in between these two things, it will be linear, as we have x to the power 1 here in this bending moment equation. Hence we need to draw a straight line. Now this is the bending moment diagram we get. This is parabola, and we have straight line here, right, and everything is negative. 15, and up to here it is 9, and this one is 0. That's it. Thank you.